unit circle?
I sure do.
Let's do it.
Yeah!
The unit circle is split into radian measures of pi over 6 and pi over 4. In a whole unit circle, there's a circumference of 2 pi at 360 degrees. So that's like having 8 pi over 4 in a whole circle, or 12 pi over 6 in a whole circle.
So let's take a step back. When counting by pi over 6, it increases by pi over 6 each time. That translates to 30 degrees when you're looking at it as a triangle. Throughout this circle, we simplify things. For example, pi over 3 is equal to 2 pi over 6.
When counting by pi over 4, it works the exact same way as counting by pi over 6, except of course you add pi over 4 each time. That translates to 45 degrees.
And for example, also it works for 7 pi over 6. So you add, after you reach 180 degrees or pi, you keep adding 1/6 or pi over 4.
Also, you can use a unit circle to find rotations greater than 2 pi. Depending if you're looking for radian measure of pi over 6 or pi over 4, you simply just keep counting from the 2 pi mark. So let's say I'm looking for 13 pi over 6. So we know that 2 pi equals 12 pi over 6. So you keep counting 1 to 13 pi over 6.
Exactly. So that also goes into coterminals. So coterminal is a radian measure that is equivalent to another radian on the unit circle. For example, if you're trying to find the coterminal of 7 pi over 4, which is right here, you continue counting from 7 pi until you reach the spot again. So you go all the way around until you reach 7 pi again. And that equals 15 pi over 4, which is the coterminal. You also notice that 15 pi over 4 is 8 pi over 4 added to 7 pi over 4, which is basically saying that you add 2 pi to whatever the original radian is.
Wow, that's a really cool trick to find the coterminal. I guess you need to pay attention to what you're counting by, though.
Yes, you do, Mariah. Yes, you do.
When understanding the unit circle, you also need to be able to find negative rotations. With a negative rotation, you start at the 0 mark like ours, but instead of counting up, you count down. So this, in terms, would be negative pi over 6, and this would be negative pi over 4. So let's do an example. Let's try to find negative pi over 3. Keep counting down until you get negative pi over 3.
That's cool, Mariah.
Yes, it is, Camille. Yes, it is.
The unit circle can be split into triangles as well. Cosine, sine, tangent, cotangent, secant, and cosecant. So when you look at the unit circle, you can split it up into quadrants like a graph. So there's the x-axis, the y-axis. And for the cosine, cosine is x. So cosine is square root 3 over 2 if you're looking at 30, 60, 90 triangle, and sine is 1 over 2 as in a 30, 60, 90 triangle. And that pattern repeats throughout the whole entire circle when you're looking at the angles. And cotangent, secant, and cosecant are all relatable for just cosine, sine, and tangent. So it's just all interrelationships for them as well. So cosine is x and sine is y.
Now let's take a look at the unit circle with all of its cosines and sines filled in.
Linear graph. Let's try and figure out what the area under the curve represents.
Okay, let's shade it in so we really know what we're talking about.
Okay, so the shading represents the product of the y-axis and the x-axis. For example, if the y-axis is miles and the x-axis is hours, the shading represents the distance traveled. So 15 miles times 3 hours is 45. So they traveled 45 miles.
Within the 3-hour period. Different techniques to find the area when the curve isn't simply flat like this include using sigma notation to find the sum of left endpoint rectangles, right endpoint rectangles, and trapezoids.
As you can see, understanding the unit circle and area under the curve is really important to understanding math. They're great stepping stones to understanding trigonometry as well.
Thanks for watching.
We love math!